find the intercepts and graph the following equations. So when I say find the intercepts, what am I asking you to find? The what and the what? The x and the y intercepts, okay? So we're going to take this very first equation here, x plus 3y is equal to 9, and we're going to find those two intercepts. So someone remind us, if I'm finding an x-intercept, how do I do that, Miles? We're going to replace the y value with 0, okay? Because remember, by replacing the y value with 0, that means that you're on this axis, which is our x-axis. That's what we do to find an x-intercept. You need to plug 0 in for y. So, if we plug 0 in for y, and we copy everything else in this equation down, we're going to have x plus 3 times 0 is equal to 9. And then remember, we evaluate and solve for x. So we evaluate first because we know that 3 times 0 is 0. Okay? And then if we take x plus 0, we get x. So we have x is equal to 9, which tells me that is my x-intercept. Now remember, your x-intercept is only going to be listed as a number. It's 9, okay? For our graphing purposes, though, what ordered pair do we know that we should be plotting here? 9, comma 0. Because the x value is 9, and you let the y value be equal to 0. So we should be able to take that x-intercept of 9, come over on the x-axis, and put a point at 9, which is the ordered pair of 9, comma 0. Okay? Then the next thing we need to do is find our y-intercept. Okay? What do we do to find a y-intercept? You let x be equal to 0. And again, think about what that's telling you. If your x value is 0, that puts you on this line right here. And if it puts us on that line, then it puts us on our y-axis, and that therefore is your y-intercept. Okay? So again, we're going to replace x with 0. And we're going to simplify and solve. So what do we know 0 plus 3y is? It's 3y. Now, this one still needs to be solved for y. Over here, when you took 3 times 0, you just got an x. That was fine. But over here, you still have to do what? Divide everything by 3. And when we divide by 3, then we get y to be 3, which is our y-intercept. Remember, again, the y-intercept, just like the x-intercept, is a number. That's it. But for our purposes on the graph, what ordered pair do we know this is? 0, comma 3. Okay, because again, you plug 0 in for x, and you got 3 out for y. So on the y-axis, you're going to plot a point at 3, which in this case is 0, comma 3. Now, I saw a couple of us do this, and I'll be honest, you're not the first or the last person I will ever see do this. Some people got these two numbers, and then they tried to pull those together and make them into an ordered pair, so they graphed the point 9, comma 3. And that's what I always talk about. Like, these are numbers that can be transformed into ordered pairs, but they're not mixed and matched like that. This is the ordered pair 9, comma 0. The other one was the ordered pair 0, comma 3. So from those 2 points, we've said, in order to graph a line, which is a linear idea, you must have 2 points. So once you find those 2 points, graph them both, connect them with your straight edge, put arrows on each side. That is the graph of that function. Okay? So questions on problem number 1. This is different than making a table, obviously. All right, and again, on your assessment, you're going to have a check on Monday. Your summative assessment is Wednesday. You need to make sure you read the directions on how they ask you to do this, because we're still going to ask you to graph using tables, okay? But we're also going to ask you to graph using intercepts. And then when we get into Unit 7B, which starts next Thursday, we're going to ask you to graph in a different way. There's lots of different ways to graph. We're just kind of exploring all of them as we go through it. Okay, so any questions on example number 1 here? Now, example number 2 is pretty much the same type of problem, but the big thing that I pointed out, or the reason I picked the number 2 here, was we got to make sure we pay attention to the signs in the problem. Okay, because if not, we're going to find incorrect intercepts. So the process that we're going to do is not any different. We're going to find an x-intercept, we're going to find a y-intercept. We just got to make sure that our arithmetic in this problem is correct. So again, what do we do to find an x-intercept? Let y be equal to 0. 3x minus 4 times 0 is equal to a negative 24. Again, evaluate and solve for x. So this is 3x minus 4 times 0, which is 0. And what do we know 3x minus 0 is? It's 3x. So we have 3x is equal to a negative 24. You still got to solve that for x. Divide each side by 3, and x should turn out to be equal to a negative 8. What order pair is that? Negative 8, 0. Because on the x-axis, we graph that value of negative 8. Because remember, that's all the x-axis is it's a number line. So you're graphing that value on your number line, negative 8 comma 0. Okay, what do we do to find y? Let x be equal to 0. So 3 times 0 minus 4y is equal to a negative 24. Now, there's a lot of people who are like, I can do most of this arithmetic in my head, but here's a perfect example of why I like to show all of my work here. We know that 3 times 0 is 0. Minus 4y is equal to a negative 24. What's 0 minus 4y? A negative 4y. A lot of times when I see people that try to do the mental math strategy right off the bat, they don't think of that as a negative 4y, they think of it as a 4y. Okay, so make sure that we understand that there's a negative there. Divide each side by negative 4, and our y value turns out to be a positive 6. So what order pair should we be graphing? 0 comma 6. On the y-axis, we graph the value of 6, which is going to be right here. Okay, and once we have our 2 points, we grab our straight edge, draw the line, and use arrows. And that is the graph of that function. All right, questions on problem number 2? Okay, so for problem number 3, here's what I want to point out. Your process isn't different. The only thing different is the equation in the form that they gave you. Okay? So, if I want to graph problem number 3, again, this particular problem is asking me, now some of you might go, can I use a table because it's already in function form? No, we're still asking you to find the intercepts. Okay, the directions haven't changed. So if I'm asking you to find the x-intercept, what are we doing? Plugging 0 in for y. So when you plug 0 in for y, you need to simplify, which there's no simplifying here, but then you need to solve for x. Well, solving for x isn't just multiplying or dividing by something now, it's actually solving a 2-step equation. What do we got to do to solve that for x? Begin by adding 8. 0 plus 8 is 8, equals 2 times x. We divide each side by 2, and x should be equal to 4. This is my x-intercept. So on the x-axis, we come over here and we graph a point at 4 on the x-axis. That is the ordered pair 4 comma 0, because again, you plug 0 in for y. To find your y-intercept, what do? You let x be equal to 0. Now in this one, there's no solving required at all. It's just a simplified problem. Follow the order of operations. 2 times 0 is 0, and 0 minus 8 is negative 8. There's your y-intercept. So on the y-axis, you go to negative 8, which is right down here, and you graph that point, which is the ordered pair 0, negative 8. And once we have our 2 points again, we grab those straight edges, connect those two together, arrows on each side. There is the graph of y equals 2x minus 8. All right. Questions on any of that opener there? Okay. So now let's go ahead and take a look at your homework assignment that you had from Tuesday night. Discuss any questions with those and see where we end up at. All right, so it's page 416. We were asking you to do numbers 1 through 8. All right, and I'll be honest, there really was not any computational work on this entire homework assignment. It was look at a graph, identify the intercepts, or here's the intercepts, draw a graph, and a lot of vocabulary terms as we go through. So number one, copy and complete. For the line that passes through the points 0, -7, and 3, 0, the blank is -7. So what you got to think about is the y-coordinate was -7 when x was 0. What does that tell us? That is your y-intercept. That should be the first thing filled in problem number 1. And then the second one says 3 is the blank. Well, it was the ordered pair 3, 0. So since the y value was 0, that represents your x-intercept. So number 1, the first blank should be y-intercept. The second blank should be x-intercept. Number 2, describe how you find the x and the y-intercepts of a line by using the line's equation. This is what we literally just got done doing here. How do you find an x-intercept? Plug in 0 for y and solve for x. How do you find the y-intercept? Plug 0 in for x and you solve for y. Okay? So whatever intercept I want to find, I plug 0 in for the other coordinate. Sometimes when I say how do you find an x-intercept, people will say plug 0 in for x. No, that's actually how you find the y-intercept. So whichever intercept I want to find, I let the opposite value be 0. Now, 3, 4, and 5. Here's something, and as I was walking around, I tried to comment on this as well. If I give this question on your assessment, and you give me an ordered pair, it's wrong. Okay? If you recall, your x-intercept is a number. It's the x-coordinate. Why don't we list it as an ordered pair? Because what do we already know the y-coordinate is? 0. When we ask you for the y-coordinate, the y-intercept, you are just giving the y-coordinate because you already know x is 0. That's what makes them intercepts. So in problem number 3, my x-intercept is 3. That's it. Not 3, 0, just 3. My y-intercept is 2. That's all you're going to put. This is part of the reason we practice with homework. So that way I can tell you how I'm going to grade it when it comes to your assessment. Okay, problem number 4. Your x-intercept is -2. Your y-intercept is +4. And in problem number 5, your x-intercept is 0, and your y-intercept is 0. Okay, they're both the same because that one happened to pass through the origin. Now, 6, 7, and 8, this is, like I said, no computational work, you just have to graph it. So draw the line with the given intercepts. In number 6, you had an x-intercept of 4 and a y-intercept of 5. Graph those 2 points and connect them, arrows. That's the graph that we're looking for problem number 6. Make sure you are graphing the correct ones on the correct axes. Okay? Problem number 7. Have an x-intercept of -6. That should be right here. With a y-intercept of 3, which should be right here. All right, from there, connect them. And there we go. And then finally, for problem number 8, you have an x-intercept of -1 and a y-intercept of -2. So that is here and here. All right, and once we have those, connect them both, and this should be the graph for problem number 8.
I just want to clarify real quick. When I was going around grading, I was thinking you were supposed to write the intercepts that these were, but that was given in your book, so scratch that. I think it was just the one that you were talking about when they need to list the intercepts versus the order.
Yes. Yep. All right, so questions on any of those 3? Now, here's what I will tell you. Graphing using intercepts will work all the time except one time in particular. Okay, and so I want to talk about this because it actually came up on your homework. Problem number 5, it asks you to identify the x and the y-intercepts. And what was the x-intercept in problem number 5? 0. What was the y-intercept in problem number 5? 0. So why can't you draw a line if that's all that you knew? Because it's only 1 point. If you were to graph an x-intercept of 0 and a y-intercept of 0, you would plot this point right here, and that's not going to be enough for you to be able to draw your line, because we know that in order to draw a line, you must have 2 points. And in this one, they gave you 2 intercepts, but those 2 intercepts create the same point. That's the only time that graphing using intercepts doesn't work. And we'll have other strategies, one of which would be graph using a table to help find the second point with that, okay? But otherwise, graphing using intercepts is a nice and efficient method for us to be able to graph linear functions. Okay? All right. Questions at all on the homework? Okay. So then, the next thing I'd like you to do is we're going to go right into our lesson that we need to continue from section 8.3. All right, and what we have left in section 8.3 is everybody's favorite. It's a story problem. So we are not going to get through this in the 12 minutes that we've got left of class, but we can at least get started a little bit with what we've got and what we're going to use and everything else. All right. So in this particular problem, it says that you run and walk on a fitness trail that is a total of 12 miles long. Okay, you can run 6 miles per hour and you can walk 3 miles per hour. Write and graph an equation describing your possible running and walking times on the trail. Okay? Then once we've done that, we're going to give 3 possible combinations of walking and running. So here's the thing. You're on a trail and you have to travel the entire trail. It's 12 miles. Okay? You can do this by either running the whole thing, okay? You can do this by walking the whole thing, or you can have a combination of walking and running. And that's what they're asking us to be able to do. At the end of the day, tell us 3 different ways that you can travel these 12 miles. So in order to be able to graph this, the very first thing we need to do is what? We need to write an equation. It's hard to graph an equation if you don't know what the equation is. So we need to begin this problem by writing the equation. Now you're going to notice that as they've gone through here, we've got different variables, okay? So we have our running time, which we're putting on the x-axis, and we have our walking time, which we are putting on the y-axis. Okay, so we need to make sure that we pay attention to those. So when I go to write my equation, I'm going to use x and y, but we're going to be specific about what these represent. So here's what I want you to do. This is not like something that's optional that Mr. Tompkins is just kind of saying, I suggest you do this. You need to do this. Okay? So we need to, if we're going to write an equation, we need to tell everyone what is x representing. So if you look on the x-axis, what does x represent?
6.
It's our running time. It's how much time we spent running. Okay, so we're going to let x represent our time running. All right, and we're going to let y represent what? Your walking time. Okay, so our time walking. So now when we go to write our equation, it's going to make a little bit more sense of why we're doing what we're doing. So let me point this out to you though. Because this problem has a story behind it, and because our variables are representing the time walking and the time running, you're going to notice that this graph does not look at all like the first 2 prior to this. If you'll notice, the point 0, 0 is here, and then all we have here is what we would call quadrant number 1. Why? Why isn't there a quadrant 2, quadrant 3, quadrant 4 in this picture?
Because you can't walk negative.
Exactly. You can't walk negative and you can't run negative times. So if I were to start having a graph over here, that would represent my time running being negative. That doesn't make any sense. If I started to include the graph down here, That's going to show that my time walking is negative. That also doesn't make any sense. The least amount of time that I can spend running is how long? 0 hours. The least amount of time walking that I can spend is 0 hours. So you're going to notice that our graph in this problem is just quadrant number 1. That's the only reason that they changed what the graph of this looked like. Okay? Now, before we start using numbers, here's what we know is happening in this particular problem. All right? We have our distance running is some number. We know it's got to be at least 0, maybe bigger. Okay? But we've run some distance on this particular trail. We also know that we have a distance that we have walked. This could be as low as 0 miles. This could be as high as 12 miles for the entire trail. Okay? But if I were to take how much distance I've ran and how much distance I've walked, what do I know is going to happen with, what's the relationship between those two numbers? They should add to give me what? They should add to give me 12. Okay? They should add in this particular problem, before I put 12 here, I'm going to put total distance. So, again, in a story problem, before you just start grabbing numbers, you got to think about what's the relationship. Here's my relationship. We're taking how far we've walked, we're taking how far we've ran, we're adding those two together, and as a result, it's going to tell me how far I've gone. Now, do we know any of those 3 things for certain? Yes, we know one of them. What one thing do we know out of those 3? We know how far we've gone. We know that we have traveled a total of 12 miles at the end of this trip. What we don't know is how long of that we walked and how long of that we ran. So over here, if we don't know these, there's going to need to be some variables over here. Okay? So somebody tell me, what do we know about when we run? You can run 6 miles per hour. So if you were to run for 1 hour, how far would you have gone? 6 miles. If you were to run for 2 hours, how far would you have gone? 12. And I realize that we're stopping at 12, but let me continue. If you were to run for 4 hours, how far would you go? You go 24. Do we know how long we ran? Do we know how long we ran? Not how far, how long? No. So we know how fast we go, but we don't know how long we go, right? So if I run 6 miles per hour and I run for X hours, how can I show that? 6 times X. Our distance running is represented by 6X. Because for every hour, I'm traveling an additional 6 miles. So again, 1 mile or 1 hour is 6 times 1. 2 hours is 6 times 2. 4 hours is 6 times 4. So if I'm traveling for X hours, it's 6 times X. Now, what do we know about when we walk? We're walking 3 miles per hour. Okay? So if you were to walk for 1 hour, you'd go how far? 3. If you were to walk for 3 hours, you'd go 9. If you were to walk for 5 hours, you'd go 15. But we're walking for Y hours. So how far is that? 3Y. So we're taking 6X plus 3Y is equal to 12. All right. Now, here's what I want you to do. There's your equation. Okay? You, as practice right now, by the end of the hour, are going to graph this equation. Go ahead. Find your intercepts and graph. All right, and then we'll come back 7th period and we'll talk about what we can do with this graph once we're done with it.